When we're studying elastomers, one of the tests we like to do is the rubber band test to show you the hysteresis effect of the rubber band. The rubber band uses energy when it expands, and then it gives that energy back when it contracts, but it never gives all the energy back. Some of the energy is spent in retangling the molecules, so we'll go up the curve and then we'll come down on a lower curve. And this creates something known as a hysteresis, and it's incredibly important in both electrical engineering, for the study of capacitors, and also for elastomers like rubber bands. So this demonstration shows that. What we're going to do is the rubber band is mounted here just in the brackets. We're going to go up about 8 inches and then down 8 inches and plot the load versus deflection. So let's go ahead and look at that. Aptly enough, our program is called Rubber Band, and there's very little to do with this one other than give it the initial separation, which really isn't terribly important. We'll take control of the system, zero our load and crosshead, there we go, and then run our test. And this will take a few moments. With thickness of the rubber band, it does plot stresses. That's actually less important than just getting the curve shape. So what you're going to see here is, as the test starts, it's going to come up and plot fairly linearly. So we can pause for a moment, and when we get up towards 8 inches, we'll knock it back down. We're coming to the end here, and you can see we're just about at 8 inches, and then it's going to come back down. You can see we're about 9 pounds. Now look what happens. This was the curve coming up. Look at the curve coming down. It's fallen below. And it will do this, and it will create this kind of teardrop shape that's called a hysteresis. And what's happening is that the energy is the area under the curve. So if we were to count the squares under the curve, we'd have the energy that was used to pull that rubber band up 8 inches. When we let the rubber band go back down slowly, it releases its energy to us, and that's what we're measuring here, this lower curve. But you notice we didn't get it all back. This in between the two curves, it kept for itself. And that's the property of the elastomer, tying in all of the retanglement of the strings, and it absorbs that energy. So you don't get something for nothing. No matter how much energy you put into this rubber band, you only get about 90% of it back. The other 10% it needs to stretch again. And there is absolutely nothing you can do about that. Here's that curve fully plotted on the software, so you can see, going up and then coming back down, and you can see the difference in the energy level. Now, if you were to do this with a spring, then you would see those curves overlap. There'd be very little difference in them. But with elastomers, you see this effect and this hysteresis effect. So it really is kind of interesting to watch. And you should do this about 5-6 times, get enough, and show the repeatability of it. I think that would make very interesting for your lab report. So go ahead and do that, and then, again, save everything out, hit the Roman numeral 3 tap up here, save it out to an Excel file so you got some nice plots for your report.